Hi, I am Mali. Welcome to the channel. Using the latest zero-shot instance segmentation tool, I was able to get 104 segment masks in this low-resolution image. I then tested out the tool on this AI image and was able to adjust the colors in post-processing. Combining Yolo World with LaMa, Matte, and Fooocus's own control Inpaint model, you can easily segment and inpaint a subject with near perfection. The workflow is designed to handle all types of images and Inpaint with intrinsic details. And you can even change the subject. Today's tutorial focuses on advanced segmentation, image processing, Inpainting, and Outpainting techniques. Let me show you my workflows, tips, and some hacks in ComfyUI. I want to thank all the paid channel members for their continued support. Except for the Yolo World custom node, all other installs are straightforward and can be done directly from the Comfy Manager. This tutorial covers 7 workflows. A basic Comfy know-how is required. The Yolo World and efficient SAM Comfy implementation is made possible by Zo. Yolo World is a real-time open vocabulary object detection tool with instance segmentation capabilities. Although its core competency lies in video surveillance and analysis, self-driving cars, and robotics, I will be using it for image manipulation via segmentation. The second most important custom node I am using is Comfy Inpaint Nodes by Ackley. The Inpaint Nodes uses the Fooocus Inpaint model, which allows you to convert any SDXL checkpoint to an Inpaint model. Fooocus Inpaint or Outpaint method is one of the best in the industry, as it uses its own algorithms and is partially inspired by diffusion-based semantic image editing with mask guidance. You can also pre-fill the mask area using the Telia algorithm or the Navier-Stokes equation. In addition, LaMa and Matte Inpaint models are used for object removal. In this tutorial, I use differential diffusion, self-attention guidance, and combine all of them to get the desired output. I use the impact pack for the preview bridge node required for Inpainting. Some of the Was, Masquerade, and Vextra nodes are used in the image processing workflow. The WD tagger node is used to get tags from images. And the graphic nodes are used from Comfy Roll Studio. A node from ArtVenture is used for color correction. The Inpaint node is one of the main nodes for the workflow. The seed and image compare nodes are used from RG3. I use Comfy Essentials to get the image resolution. And finally install the Yolo World Efficient SAM custom node. The requirement for the custom node is set to a lower version of Inference. Comfy, however, requires the latest version and the node does work on it. After you install the node and restart Comfy, you might get this warning. When this node was released, the latest version of Inference was 0.9.13. This custom node works until version 0.9.15. However, it breaks with version 0.9.16, released on March 11th. I have informed the dev about the issue. The Inference version of 0.9.13 should not interfere with Comfy functions. RoboFlow Inference is a set of tools that simplifies deploying computer vision models, particularly those trained on the RoboFlow platform. These include ClipSeg, Segment Anything, and Yolo World. If, for some reason, your inference gets updated to the latest version via Comfy Update, I have mentioned the steps to downgrade to the required version in the description. Any future updates for this will be in the pinned comments. For the Yolo node, download these 2 files. They go into the Yolo folder in Custom Nodes. Next, open this web page and download the Fooocus Inpaint head and the version 26 patch files. They go in the Models, Inpaint folder. Then, from the GitHub page, also download the LaMa and map models. They also go in the same models, Inpaint folder. Let's start with the load image. Add the main Yolo World node, the model loader, and the efficient SAM loader. There are large, medium, and small models. I would not recommend the small model, as it fails to detect some objects. The medium model is acceptable. I would be using the large one for the tutorial. For the device, you have CUDA for NVIDIA GPU, or you can just use the CPU. Connect the image, add a preview and a mask to image node. I am going to connect the image with a WD14 tagger node. This is very useful as it can list some tags in the image. Let's try out an image. Yolo World model can detect objects that it hasn't been explicitly trained on. You do have to play around with this, and I will show you some unique examples. Just type in what you naturally see, let's say, a car, for example. To select multiple subjects, separate the keywords with a comma followed by a space. This is a combined mask. If I turn off mask combined, I can get separate masks for each subject. Separating the masks allows you to select a specific mask to pass on in the workflow. The first mask is labeled as 0, the second as 1, and so on and so forth. So, if I want to pass off only the car, I will enable mask extracted and select 0 in the mask extracted index value. To select the bike, change the index value to 1. The system has a slight learning curve. For example, if I add person to the prompt, the selection dynamics changes. So now, the confidence value has changed, and it is selecting another car out of frame. This behavior is normal with the Yolo World node. Here, if I want a combined mask of only the car, the bike, and the person, I should try increasing the confidence threshold to 0.3. Another quirky behavior is if it cannot detect the specific subject or object, it gives an error. The tagger here is helpful as it identifies some keywords. I can then use these in the Yolo prompt. You can increase the threshold and character threshold to expand this list. Let's try a very low resolution, poorly shot image. This was shot via mobile in low light. The poor quality and blurring are evident here. This will obviously confuse the Yolo model for segmentation. Let's try a simple keyword car. Changing the confidence to default. It missed the car with the blur, which is what you would call a false negative in detection. There is a way to correct this. Yolo uses bounding boxes for detection. It creates a box that has the entire subject or object selected. There is something called the ground truth. The dataset used in training has ground truth bounding boxes. These boxes define the exact location of each object in the image. The intersection over union threshold is the percentage of overlap between the predicted box and the ground truth box. A higher IOU indicates a good prediction, while a lower value signifies a poor prediction. In simpler terms, the IOU threshold is like your minimum acceptable accuracy. The default for the node is 0.10, which I find acceptable. As per the research paper, they use 0.5. However, a higher value may sometimes cause false positives and vice versa. I recommend starting with 0.1 and then increasing or decreasing in case of a false positive or negative. Let's increase the value to 0.5 and see if that helps detect the center car. This is another low-resolution image, and it has a lot of objects and subjects. Let's say you want to mask this text. The error is because it could not detect it. Reducing the threshold to 0.01. The efficient Segment Anything model works very fast and is highly accurate. Let's try another keyword, goggles. Because of the low threshold, it has mistaken some objects as goggles. For the object here, it could not distinguish between goggles and the bowl. And these two objects are not goggles at all. Keep in mind this is stressing the system as the image is very low resolution. You may say this is the model's limitations. If you remember earlier, I said the whole detection dynamics changes if you change the prompt. Let's try that. This is better, but it still struggles with masking some objects. For example, here, it has now masked the entire head. I want to show you one last example. Say you want to select this person along with the shadow. Later in the tutorial, I will show you how to completely erase objects from images with high accuracy. The important thing is that you should know how to mask it using YOLO. Let's try shadow with the default threshold value. You can see how accurately it has been masked. Now, I will also add woman to the prompt to select the subject. I won't be able to change the threshold so that it only selects the center subject and shadow. The shadow has a lower confidence value than the other selected woman. I can try to change the prompt and say, woman with orange bag. And this works beautifully. This works way better than anything we currently have. Comparing it with grounding Deno would be a good measure. Firstly, I can't separate the mask directly in grounding Deno. Secondly, it is slower and highly inaccurate in comparison. Whatever settings I tried, I could not get a well-defined mask for the center subject and the shadow. I have tried and tested a lot of images, and in many instances, grounding Deno fails. I am specifically choosing this image because it is a bit difficult to post-process. First, I will apply a color or gradient to the entire image. Then, segment individual elements. And finally, cut that element and paste it over the main image. The color or gradient should match the resolution of the source image. So first, you get the resolution of the input image with the getImageSize. Add a color gradient node from ComfyUI Studio, convert the height and width into inputs, and make the connection. For a static color, the start and end colors should be the same. For the tutorial, I will choose a gradient. You can also select custom and input any hex color code. Using an image blending node, you can overlay this gradient over the original image. Image A would be the source, and image B would be the color or gradient. Change the mode to color and percentage to about 80. Add a color correct node at this stage. This node allows you to fine-tune the color grading further by editing the temperature, hue, brightness, contrast, saturation, and gamma. Add the Yolo World nodes as shown previously and connect with the source image. I am going to segment the top clothing first. I probably need to reduce the confidence threshold. And let's increase the IOU to 1 as well. I am not able to segment the top clothing of the first subject correctly. As I said, this is a problematic image. Trying a different prompt. I tried many variations, and this is basically the best I could get. I can work with this. What you need to do now is duplicate the Yolo node and subtract the other mask from it. Let's try the keywords short pants and arm. Now, simply combine the mask. It doesn't matter if there are extra elements here. Add a bitwise subtract mask node and connect it with the Yolo mask outputs. We can get rid of these extra artifacts by adding a grow mask node. Reconnect the mask subtraction with the grow mask outputs. At a value of 2, it eliminates all the artifacts. The cut by mask node lets you cut the masked part from the source image. Connect the source image and the subtracted mask. Okay, I made a mistake here. Ensure you connect the color blended image output. Perfect. Add a paste by mask node. The cut by mask output connects with the image to paste input. Use the subtracted mask output as the mask input. The image source is from the load image and not the blended output. Change the resize behavior to keep ratio fill. The color has changed to blue, and this is good enough. I am dragging this node next to the load image. You can right-click and copy the output. Then, select the load image node and paste it using the keyboard shortcut. I had trouble getting the mask because the color was too blended with the background. Mute the bitwise subtract and the second Yolo node, and try the shirt prompt again. As you can see, Yolo World can now perfectly select all the individual clothing. So, I am going to use mask extracted to select each individual element, bypass the bitwise subtract node, and repeat this process. I am fast forwarding the process as it is repetitive. I will slow down to show you some other tricks I used. There is no limit to this, and it does not take any sampling processing, so it's quite fast. You can repeat this process for each subject or object that Yolo World can segment. That's the only limiting factor here. I want to show you a little bit about bottom clothing. Pant as a keyword doesn't work for this image, but short pants do. I will keep the settings the same, select each mask, change the color, and repeat the entire process. This is the output I got after doing this for about 10 minutes. Once the workflow is set up, it's pretty easy and straightforward. For the background, I just entered the keyword background, and it segmented it correctly. If, for some reason, it cannot, then select the subjects and invert the mask. Before I proceed with the Yolo and Inpaint integrated workflow, you should know how to convert any SDXL checkpoint using the Fooocus patch. For the tutorial, I am using the Juggernaut V9 checkpoint. The self-attention node was added to Comfy in December last year. It improves the quality and detail of images generated. Self-attention analyzes the image during the creation process and helps the model focus on important relationships within the image. Differential diffusion is now a standard when inpainting in ComfyUI. Instead of replacing the masked region in one shot, differential diffusion works through multiple smaller diffusion steps. With each step, the model reduces the noise in the masked area while also being influenced by the surrounding image and your prompt. This leads to a smooth, gradual transition. The main advantage of using differential diffusion is that you get a seamless blend, and in the process, it manages to preserve the details as well. Here, I am setting up a standard VAE encode Inpainting workflow. I am using a non-Inpainting checkpoint. Typically, checkpoints trained for Inpaint offer a smoother blend. I will use the same prompt for consistency. Let's also look at the Inpaint conditioning method before comparing it with the Fooocus patch. This is way better. Duplicating the sampler again. Add the Apply Focus Inpaint node. Connect it with the differential diffusion and sampler. Add Load Focus Inpaint node. Change the head and the patch models. Add another VAE encode for Inpainting node. Then, connect the latent output to the Focus Inpaint and sampler input. Remember that the VAE encode method with the patch is used when replacing a subject or object within the mask. See the difference. This patch method will work with any SDXL checkpoint. I cleaned up the previous workflow to only include the Fooocus patch. Let's change the prompt to a large polar bear on the street. As you can see, this leaves a very clear masking line. We will clean this up. Add a preview bridge. This is for manual masking without the saving and loading. This node is a 2-in-1 node from the Inpaint custom node. It's the VAE encode and condition combined. This node only works when you need to refine the image or make smaller refined changes. You typically use a lower than 1 denoise value. I will use this to blend the masking outline with the background. The latent Inpaint connects with the Apply Focus Inpaint. And the latent samples connects with the K-sampler input. This method blends the Inpaint perfectly. To recap, you use the VAE encode Inpaint node with the Apply Focus patch to replace a subject or object. Then, you extend the workflow by adding the VAE encode and conditioning node, masking the visible mask outline from the previous Inpaint, and reducing the denoise to less than 1. In this workflow, I will showcase some techniques for perfectly removing a subject or object from an existing image. Let's try using this image of a person sitting on a bench. The gaps in between the bench should be challenging. Add the 3 Yolo nodes as shown previously. We'll use the prompt, person, with the default settings. Let's first try using the selected mask and see the results before doing anything else. Add the Grow Mask node. Search and add the Inpaint using Model node. Connect it with the Load Inpaint Model node. This model is called MAT, which stands for Mask Aware Transformer for Large Whole Image Inpainting. This one is quite impressive. It's trained on a larger dataset. The second model, trained on a smaller dataset, is called LaMa, which stands for Resolution Robust, Large Mask Inpainting with Fourier Convolutions. I will use MAT for this image. The performance of the model depends on the image. I try using both the models to see which does a better job in the initial stage of removing the subject and continue from there. This is the area filled in by MAT. Notice that it is a bit low resolution, and you can clearly see that something has been removed. I will try to fix this with near perfect resolution comparable to paid apps like Topaz AI, and for some images, it's even better. For this specific image, LaMa performs very poorly. I will show some examples of LaMa outperforming MAT. Adding the load checkpoint, conditioning, VAE encode, and Inpaint conditioning nodes. Ensure you connect the image from Inpaint model output to the VAE encode and conditioning node. The Grow Mask output will connect with Mask input. Here, it's best to put a positive prompt, bench, park. If you don't, the model usually generates a person sitting on the bench. Like before, adding the self-attention, differential diffusion, and connecting it with the Apply Fooocus node. Add an image comparer node. Connect it with the output and the original load image. This is the main issue here. I can improve on the other details as well. Since the Inpaint technique requires surrounding pixels, I will mask the bench backrest area manually. Now add a bitwise mask addition node. You want to combine the YOLO and manual mask. Make sure that the YOLO mask output is singular either by mask combined or mask extracted. This wider mask area should help. Another thing that might help is the blur mask node. This node blurs the mask area, which you would normally use to preserve the colors. The fall-off is the edge of the mask, where the blurring effect gradually fades from its maximum intensity to no effect. Connect the blur masked area output to the VAE encode input and Q prompt. This is very good, but we can add another step to improve it further. Duplicate the K-sampler and run it via a second pass with the same settings. After this step, the output is very refined. Here are the results with different images. This was done using the LaMa model. Matte performed poorly here. Here's another one using the LaMa model. The details in this are insane. These are all done using the same settings. The only changes in the settings are either the prompt or the grow mask value. And this last one. The prompt for this one was empty. Both models perform equally for this image. You can combine everything shown in the tutorials so far. Starting with Yolo World to select the subject. Then, I used the LaMa model to remove the subject. I refined the image with a positive prompt, VAE encode and Fooocus apply patch. I did 2 passes for this. I further connected the output with a preview bridge and made a manual mask for the mammoth. Here, I experimented with a refinement VAE encode and Inpaint conditioning node. Remember, if you use just the VAE encode, then you should refine it further using another pass via this node. For outpainting, create the basic refined Inpaint workflow. Use the VAE encode and Inpaint conditioning node with the Fooocus Inpaint. Here, add the pad image for outpainting node. Change the left value to outpaint on the left side, say 128 pixels. Remember that the model will use some adjoining pixels as a reference and try to outpaint. Add a fill mask area node after conditioning. Connect the pad image to the fill masked area. This has 3 settings. For outpainting, don't use neutral. It is just a plain mask. Telia is an algorithm, while Navier-Stokes is an equation. Both work, but they give slightly different results. It is recommended that a blur mask area be added for outpainting. Connect it with the pad image and fill masked nodes. Now, complete the remaining connections. For outpainting, go either horizontally or vertically. Once you do it horizontally, for example, proceed vertically. Start with 128 pixels, and you can go up to 1024 resolution at a time on either side. Let's change the value to 768 and try out Telia. So, there is just a bright light on the right, and there is nothing wrong with the generation. The same is evident from the preview. Let's revert back, and then I will show you how to outpaint vertically. Duplicate everything from the pad image node, right until the preview and save image. The VAE decode output will connect to the second pad image for outpaint node. The benefit of doing this is that you can use different fill mask area styles for horizontal and vertical. Also, it's preferred if the whole image is generated before changing directions. It yields more accurate results. Using the Fooocus apply patch, you get very good results for outpainting. Here, you can also try using a prompt. Let's say, grass, faded, out of focus. I hope this tutorial was helpful and you learned something new in Comfy. Until next time.